Good day, ladies and gentlemen. Heartily word of welcome to all the EGD colleagues, to all the EGD learners. It's really a privilege in this position helping you guys with the engineering, graphics and design, especially the learners who are attempting a mechanical drawing for grade 10 for the first time. Now, with the mechanical drawing, it can be, of course, more complex. You know, machines and those type of things and mechanical parts are always complex with all corners, shapes and whatever goes with that. But to a certain extent, EGD will guide you into a process. Now, I must first tell you that in grade 10, on grade 10 level, you will only work with a casting. Now, a casting is something like, I used to say, it's like melting a chocolate rabbit for Easter, for instance. It's melted material that you cast into a mold, and then if you take off the mold, you will have one unit. In other words, it's not 2 or 3 units. For grade 11 and grade 12, you will have assembly drawings. Now, assembly drawing is where you take 1 and 2 parts and assemble those two by means of a nut and bolts, by means of a rivet, by means of many ways. And then, of course, you can understand with the grade 12 exam paper, there can be up to 11 different components that you have to add and compile to make a unit and work as a unit once you're done with the question. Right, if I can show you or introduce you to the slides. First of all, you must understand that you're going to work on a flat piece of paper. So now, if you work on a flat piece of paper like this one over here, you will see that the examiner in an area over here will give you the question part of it. All right. Now, of course, if there's enough space on the same page, if there's not enough space, it will be given to you on a separate page. And the same with the question. If the question can't fit in onto this drawing sheet that you see over here, you will obviously have to go for a second page. And in grade 11 and grade 12, it goes up to a second page, and even grade 10 in some cases as well. All right. Now, we have done on the previous session the placement of the views. Now, it's third angular geographic projection. So in other words, this will be the front view. The top view will be seen from above and placed on above. Like 3 tells you, you go back to your track, you go back to your track. And if you go like this view over here, for instance, for the left view, you will see it from the left, but 3 will tell you you're going back and you're going back towards this specific area. So that is what you will see in regard to the left view over here. So now, obviously, the front view and the top view will always be above each other or below each other. All right, the front view on the bottom, top view seen from above, taken back and placed on this position over here. All right. If I should go for, say, for instance, a right view, the placement of the right view will, in other words, be on this area, in that position over there, because it's been seen from the right, and then going back to your track means that you will take it towards this point. All right. And then, of course, for the left view, it will be placed on the left view. You will look at it from what will it look like from the left, and then it will be going back and be placed on the left view. Now, of course, you can imagine this is your views that you will get, but you can also get a bottom view. All right, to see what does this look like from below. What does it look like from underneath, in other words, if you see it that way. So this is underneath, looking from below, then placed on below. It's still third angle geographic projection. All right, so that's what you will see. Now, of course, if we go maybe back to the previous page or this page specifically, you will see that you can't just squeeze the right view in and there's basically no space over here while there's plenty of space on the left hand side. You can't squeeze the top view in a small area while there's plenty of space on the bottom view. So therefore we have to place the views in such a way that we have ample space, of sufficient space, if you can see it that way. Now, we know that the front view should fit on this area over here. So if we accommodate the size of the front view in this area, if we accommodate the area, remember, this is not the placement of the view, it's just accommodating it from here to there, the total width of this can be measured up to that point. If we have to accommodate the right view on this part of the paper, the width of the right view or the depth of it will be basically from left to right. Now, this is the space that we're talking about. In other words, that is the area between. So now if we divide this area by 2, and add 10 millimeters to either side, I can say that now, that if I place this view over here from that point towards there, this is the remaining space on the other side of the view that will be remain behind. And if I take this view and I place it and squeeze it in over here, it means the distance that will be remain from this part over here will be the remaining area that will be equal to that to the left, since we've divided this into two parts. All right. Then from there on, for the top view, this is the depth of the top view. How deep does it go in other words? All right. So we can also say it needs to be accommodated by this size. We take this distance from there to there and divide that distance by 2. And then, of course, we can say, right, let's go 5 up and 5 down to keep the drawings 5 millimeters apart from each other over here. So that's the middle point, and then from there, 5 up and 5 down gives me 10 millimeters apart from each other. And now I can shift my drawings in position so that I know that this distance from there to there, or the distance from there to there, will be equal the distance from there towards that point, and the distance from top to the page to the top view, and the distance from the bottom of the page towards the front view will be equal in distance, since I've worked out this system perfectly. So this is very important to understand. Now, of course, a drawing can be longer. There might be some levers being added onto which stands out further. So therefore, we have to accommodate the distance longer, the total distance of the front view from there to there, the total depth of the top view, the total width of the right view or the left view, whatever the case might be. Now the examiner is giving a left view, but is asking for a right view in that case. Right, so this is what we need to show about that. All right, then also we're going to section this drawing. We're going to cut it in half, in other words. Why should we section this drawing? Because most of the times there's some detail inside the drawing of which you need to know, of which you have to be familiar with. All right, so the only way to show that is by cutting it open and show the detail which is inside. Now, how are we going to cut the drawing open? Now, remember, this is first angle orthographic projection. In first angle orthographic projection, that will be a solid line like this one over here. All right, so there we go with a simple solid geometry, and then that line was basically cutting it open towards that point, saying I'm going to cut this open, and then we're going to show the saw marks, or we're going to show the hatch lines, if we can see it that way. All right, so remember, it's always you take away which is in between. So if I need to go to the top view, which is on this place over here on first angle orthographic projection, remember that is going to be first angle orthographic projection. That means that I will remove this part that is in the way between me and the saw marks or the damage marks or what the cut mark itself. So therefore I'm going to remove this part, and I'm going to draw the rest of the drawing, which is the rest of the remainder drawing at that point over there. So there's the saw marks over there. All right, so I can also get the true shape. We will get to that detail later on in the year. The true shape tells you it's the true surface that you will see in this regard. So there we go with that. Normally, if this is standing on 45 degrees, this one will stand up straight if it's already standing on 45 degrees at an angle. So therefore we will use the set square and t-square in drawing those lines parallel. Of course, it can also be horizontal, but it will look funny if we have got 45 degree lines and these lines are all running 45 degrees up there. All right, so there we go with that part. Now we're back to third angle orthographic projection, which is third angle over there. Now remember, this is my front view, this is the top view being placed on top, and this is my left view placed on this side. So now it's different to what we have had on the previous page. It's in this case third angle orthographic projection. Now of course, there is, if I look at it from this direction, from this way, there's detail I won't be able to see and detail I won't be able to see. And the only way to accommodate that is by means of some sort of hidden detail lines. But what if I want to show the detail in there? Then I can say, or some other drawings itself, then I can say I can have a section part, I can cut it open, in other words. All right, so in this case over here, what you see in this case is a simple drawing. This is an assembled drawing. Now this is not what you're going to have in grade 10. Sorry, you will have it in grade 11 and grade 12, assembled drawings. All right, now this is where I have got one part, I've got a second part, and I have to join those two parts with each other by means of a process. There we go with joining those two with each other. In this view, I'm not going to draw it separately. I'm going to join those two with each other. So therefore, if I join them with each other, I obviously get assembled drawing. Now there's the assembled drawing that you see over here. All right, so that's the assembled drawing. It's been assembled, in other words, if you can see it that way. All right, section drawings. Now you have to understand that this is a section drawing. In other words, we're going to cut this drawing open. I said to you on the previous slide, we want to see the detail inside here. It's been given as hidden detail, but now we're going to cut this off and we're going to remove this part over here and see what is remaining on that part over there. All right, so now in other words, we're going to take a knife, we're going to cut it open, and that is done by means of a section line, a cutting plane. It's like a plane that you will get that has been cut in the process. It's opened up in the process, right? So once I cut this area, it means the following. All right, so therefore I'm going to cut this open. I'm going to remove the front part over here, and this is the remaining part that will left over. So therefore those lines at there, at that point and at this point over here, will become solid lines, not hidden detail lines, because you will be able to see these things now. In other words, there you go with those lines over there. All right, so that will be visible now. Now, of course, I've cut this part open and I've cut this part over here. So that's where we get to the hatch lines. Now, where does the hatch lines come from? This is, if this is the area or the surface, I will use my 45-degree line at about 5 millimeters apart from each other. Over here, you will draw those lines in to find those lines parallel to each other. Right, so there we go with those lines, 45 degrees, and it will be more or less 5 millimeters apart from each other. All right, so that's what we have over there. Then over here, the cutting plane itself, there's long regulations in terms of that. Now for the exam paper, the National Senior Certificate exam paper, 12 marks was asked from cutting planes. So now this portion I'm doing now, 12 marks, 12 half a mark, so therefore for paper 1, paper 2, it's 6 marks, and then divide by 2, if you total that paper 1 and 2 to get a percentage, it's 3%. So 3% only because of the hatch lines. Now imagine for yourself, you got 79%, and you desperately want to have a distinction in engineering, graphics and design, and you've missed your 3% because of this. I think you can kick yourself for that. So therefore, rather pay attention now. What happens over here with third angle lithographic projection, it will be a center line. Right, the cutting plane will be a center line. Now that center line will be consisting of 20 millimeter long lines, 4 millimeter of gaps, and 4 millimeter of lines. And that's where we get to this part over here. Right, so then it will always end with a long line. There will always be a long line on the ends over here and on the end on that side over there. Besides that, you will also see that this is like a knife. This is like a cutting plane. In other words, you have to have a handle. So that handle is the darker ends on either side of the line, the cutting line itself. All right, and then we're going to have arrows. Now the arrow is very important, must point the right direction. Now this is the arrow. You can see it's a bit thicker than your dimension arrow. The dimension arrow is about that thick on this side and that thick on the left hand side. Now that is basically twice the size, and it's also twice the size of the thickness of the pencil of what you see over there. All right, so there we go with the cutting plane. Like I said, direction is important, and then also the arrows are pointing to the remaining, towards the remaining portion of the object itself. In other words, what I see over here is the arrow will point this direction, because I'm looking at it from this direction, take it back and place it over here. So that's third angle lithographic projection. Look at it from this way and go back. Look at it from this way and go back. So in other words, I will remove this part over here, and then this remaining part will be the part that will be left behind. And of course, I want to see the saw marks, the cut marks itself. So by removing this part, I will see the cut marks, and that is what you will see in the process over there with the hatching lines, all right, or the hatch lines. But you can see that the center line, you can see the darker ends, you can see the arrow is pointing, and all those type of things in the right direction. Okay, so you name it afterwards. You name it AA, and then this view over here will be called section view on AA. So that's important. That's the sectioned view on AA. So if it's been cut there, this has been removed. I want to see the saw marks over there, and then from there on, this is where the hatching come from, like I said just now. All right. So if you go back to our original drawing, you can see that this part is a solid part. There's no parts in between. Right. So in other words, should I cut through this? It is a casting. All right. So if it's cut off, in other words, totally cut off, it means that with the casting, it will have a sort of line that you see over there. And if I cut through that by means of this, that line will fall away. Why? Because it's been casted like chocolate, like I said, cast it into a mold, one piece of metal it's made out of. It's not pasted on or something like that, like the previous one. That line that you see over there is the ridge that you see over here on this part. But the moment I cut through this on that line itself, it means that I'm going to cut through the center of it. I'm not going to see the ridge over here. I'm going to see this part over here. And that's where we end up with that line. Right, now in this case, the same drawing, but there's a gap between the two. Can you see the gap there? Alright, so if I cut through this part over here, you can see it for this view now as it is. There is a line over there because it's because of the ridge that you see over there. Alright, so if I cut through this part over here, it means that now I'm going to cut through this, but now of course I haven't cut this part over here. With the previous one it was cut because it was solid. This one is standing deeper in, about 5 or 10 millimeters deeper in. And then therefore that ridge will be over there, so that's why you still remain with that line over there. So it's fine observing what is actually happening over here when you do something like that. Now, okay, so this is the cutting plane. Now this is an offset cutting plane. Alright, so this is the part of the 2019 and 2018 exam, National Senior Certificate exams. This was all part of this part over here. Now remember I talked about the handles that you get there, but the moment it bends up to this point and goes from there further onwards, it also have got a handle on the corners and also have got a handle on the corners, which is a bit darker to what the rest of the line is. Alright, now if I cut this, it means that I'm going to cut only a portion out of it. That part's going to fall away now. So I will see this part over here, and I will see that part of which is that over there, but only this part has been cut. So therefore the part that's in the way will be removed. So I'll remove this part, and the cut part will be remaining behind. So therefore that is the part that will remain behind. Alright, so that's what you see over there. And now because of the fact that it bends in all different directions, I need to show those lines over there. It's very important to add those lines as darker corners of that, or the so-called handles we talk about. Alright, so if we go further onwards, if it's a hollow object, in other words this object is hollow, you can put your hand in there, it's hollow there, then this will be a center line that goes downwards there. Alright, so now what if this object is solid but cut on this corner? In that case it will be a solid line over here, but careful, it's just a type B line. It's not a type A line, it's just a type B line. I know it's been cut off there, I know it's been removed there, but now it's not going to be taken away there. Alright, now if you do the hatching, the hatch lines itself, with the assembled drawing in grade 11 and grade 12, you will have to accommodate the different material it's made out of. Alright, so if I cut through this part over here, the one side of the material and the other part of the material will be hatched into different directions, saying it's one material and that's another material over there on that side over there. You can see that the second material over there is all the same object, so therefore the direction is the same for both of them. Right, now there is a third part, a third extra area that's been added onto this part. Of course the first material will be in the one direction, the second material will be in the other direction, but now it's the same direction of what it is over there, so therefore I will make this one smaller. I will take this as smaller hatch lines, not 5 millimeters, but about 2.5 millimeters apart from each other, in order to show the difference between that and that material that you see over there. Now this part over here is the reinforced rib or a web. Now here you can see in 2019 this question was asked. Sometimes, I've also explained it on the previous slideshow, sometimes when you have got lots of strain, lots of force being added towards this part and that part, it can often break in that area. So what they do is basically they make it stronger by means of this triangular like piece of material that they weld onto that part over there. Right, now just be careful. If I cut this in that area, in other words I cut it off at that point over there, it means that this reinforcement can take up significant space, and it's a lot of time in doing so. So what you will do is you will fence it off by saying this is where it's supposed to be. Although there's no seam, although it's a casting, fence it off, and then you keep this area clear of hatching, not wasting time in doing the hatching on that area, in other words. Right, so that's basically what I want to say to you. Now here you can also see a material made out of a certain object, or object made from material, and then that is all a casting. It's all the same material it's made out of, and there's your reinforcement webs that you can see over there. Now if I, so in other words, should cut it open, it means will be open up there. This part will be removed in front of me, and there you can see the reinforcements over there. Right, it's a casting, so therefore there's no seams over there. It's been melted into one another. You fence it off, and you do the hatching part of that inner part itself. Keep it clear, and the hatching of the other part. Now this part, you can see it's solid. It's a solid piece of material. Right, so if I cut this part open on that point, it means it will be removed. The front part will be removed, taken away, and this is not a web. It's a solid area. Right, so that is solid in total. So therefore, you're going to do the hatching of everything over here. All right, so that's what you want to emphasize on that. Okay, then hatching of an internal hole. Remember, this is a piece of material. If I cut through this part in half, I will go from the side where the drill went in to the other side where the drill went in. That will be all hatched from side towards side. All right, so that's what you need to know. But now, if I get a thread that's been turned into this part, this is grade 11 work, the thread will go into the material, but still you will be seeing the solid material inside there and inside there. So the hatching will go all the way to the side of the hole, not to the side of the thread that's been turned in. This is more to grade 11 level. Now if I take a bolt and I turn the bolt inside here, the bolt is a round object, so therefore round objects won't be hatched, so therefore there's no hatching in that area. There's no hatching in that area, but still hatching there and still hatching in that area where the thread was placed. All right, so that's what you will see in that regard. All right, so take care about those two. All right, then of course the top end of a stud, there's some different features that you have to know and take care of. This is back to hatching, but still on paper 1. So in that case, there are some hidden detail behind the hatching. I also was made you aware of this on the previous slideshow. Then of course, if there's large areas to be hatched, you can leave an area open for dimensions. Over here, if it's a very large area, you can sort of fence it off without lines and say it's actually carrying on, but I'm only going to do the detail on this side over here. It's also applicable. Now this is a bearing. You can see the bearing has got lots of detail on how the curves look like and where the ball bearings fit into the bearing itself, and the outer and the inner flange that you can see on this part. And then sometimes there's also some detail about what goes around this part over here. Now of course that can cause a lot of trouble in doing the view like this one over here. So instead of that, we will take the size of the bearing from corner to corner, and we will reproduce the bearing over here. We draw it over there, and then from there on we do the across from corner to corner, indicating that what you see over there and that what you see over there is actually the bearing and the detail of the bearing, without wasting time, in other words. Right. Then over here, this is a partly sectioned area. In other words, you don't want to, and in this case this is a round object, so you're not going to cut through a round object itself, so therefore you just want to show the detail of this, and in that case you will partly section. Just a part of it will be in section, the other part won't be in section. That's a part section, or 'n gedeeltelike snit in Afrikaans. This one is a revolt section, a ventel snit in Afrikaans, or a revolve section. It's like revolving around a point, so therefore this is actually, if I cut it off and I take this part and show what it looks like, this is what the shape will look like. But now I only took this part over here and flipped it around to give you the idea of what is going on in this area over here. The same with the spoke going in deeper. Is that square, is it rectangular, or whatever the case might be? In this case, it points out to you it's an oval-like shape of the spoke itself. All right, so that's a revolved sectioning. You will be able to say whether what is shown there, a revolved sectioning, or show a revolved sectioning on the drawing itself. So therefore then you have to go this route by drawing that part over here. This is removed sectioning. It's been removed, verwijderde snit. It's been removed out of this area, so therefore I've cut it there and then removed it. I've cut it over there and then removed it and placed it at some distance over there. Now what about a soda tin or something very thin to if you hatch that? Of course there's no space for doing hatch lines, so therefore we will just go with a bit of a darker line and indicate that object as a darker object from that point over there. So that's basically what you see in this regard. All right, this is now successive sectioning. So it's one after the other one, after the other one, after the other one of what you see there. It's opeenvolgende snit, so therefore it's been sectioned at different areas on the shaft itself, and it points out to you the profile at that specific point as you carry on. So that's what you see in that regard. All right. Then over here, the aligned sectioning. It is not aligned, it's not in line with each other. All right, so now I have to, you can see the arrow is pointing straight towards that position. The arrow is pointing straight into this direction. So now, of course, nobody can look like that, where one eye look into the one direction and the other eye look into the other direction. So what will happen now is we have to get them all in line over here, get them all in line, pivoted over towards the in line over here, and that's why it's called aligned. It's been aligned now, and now if I take this then back, I will draw this view over here as what it is normally if it was cut on that area. Remember the arrows, this part will be removed, so therefore I will see that and I will see that. Now it's been taken out to that point and it will be taken back there. All right, so there's no oval circles or nothing of that with the aligned sectioning. You align it into line with each other, and then from there on you remove it to what that point is. All right, now this is with gears. Now you all know what a gear looks like and so on. There's a lot of detail in the gears itself that you have to show and indicate. So if you need to draw a gear, it will be, in this case like over here, it will be either opened like what you see over there, and then the section line over there. That section line or the hatch line is basically the line that's in between the teeth. It's also that line on the side view over here, in other words. And it can also be hatched right to the end, and it can hatch right to the end over there, and that is basically then the center line that's been appointed to indicate the gear itself. All right, so this is the way that the gear was asked. This was also asked in 17, 18, 19 and 20 gears was asked in the National Senior Certificate exam. All right, so this is what you see in this regard. This is a spline, a shaft that can move inwards and outwards. There's a lot of detail that you can show. Normally you don't hatch this, all right? You don't section gears, in other words. This is rivets or pins. Rivets in this case, you also don't hatch. You keep it clear. You don't cut through those. Rivets itself, rods like a piston rod, like a rod like this one over here, a threaded rod like that one over there. Normally you don't cut through them as well. And then this is a dowel. Now with dowels you can cut off the head and show what it looks like if you hatch that. Now of course there's no space for drawing small little hatch lines over there, so therefore you're going to color this part and you're going to color that part in as has been hatched or has been sectioned. But in the length of it, you're not going to cut through that. So in other words, we never cut through the length of a dowel or a shaft or something like that. Okay, these are pins. You can imagine for yourself they are far too small in order to hatch. So therefore, we keep them clearer as well. With washers, normally with washers you don't do any hatching on. And then also with a stud, which is also a threaded rod or a piece of a rod itself, you're also not going to section. So no sectioning on that part. With the bolt, no sectioning allowed on bolts itself. And the same with nuts. You're never going to do hatching on nuts if you need to draw the nut itself. Keys, again, like in the case of a dowel, with the key, you are allowed to cut. You are allowed to take off this part over here, but you're not allowed to cut through the length of any key. There are different names attached to these keys that you see over here. But yes, it's all different. Now, what's the purpose of the key? The key is basically to make the shaft and the pulley a unit. All right. So what happens over here is that will slip into this bedding of the shaft, and once it's there, the whole unit will start moving in towards that part to make this a unit. So now, if it starts turning, the whole unit will be turned as a unit itself. Right now, if I cut through this part, this is a fainted detail of what does it look like inside there. You can also see it goes deeper into the shaft itself. So therefore, that's the area where it goes deeper into the shaft. That's the area where it goes into the pulley. The key, we said we are not allowed to hatch or to cut through. The pulley we've cut. A shaft we're not allowed to cut through. So therefore, in that case, only a partly sectioned area will be visible as cut, and we can see the bedding of the key inside this area how it fits in on that part over there. All right, so there's the key way that you see in that regard. All right, now it's turning as a unit. All right, ladies and gentlemen, this is according to the slideshows I can show you. If I need to show you some old exam papers on what the examiner did in grade 10 level in the past, you can read through the question yourself. It's pointing out that it's given all the diagrams and everything that goes with that part over there. And a section front view is required on cutting plane AA, and a right view over here is also required. All right, insert the title and the scale and the correct symbol of projection that you have to add once you're done with that. All right, so this is what the drawing looks like in a isometric drawing. In other words, a sort of three-dimensional view that you can see over here. And this is what the drawing looked like. Now the examiner is asking for the front view, which is this view over here, and it's asking for a right view, we said. All right, so the right view will be seen from the right-hand side and will be placed over here. So the front part of this, it looks like a car or a delivery vehicle or something like that, but has got square windows over here. So therefore we will draw this portion over here in this area over here. All right, so again we have to make sure that we understand on our piece of paper that was given to us, that is the question part of the paper. If we go to paper 6, this is what the examiner is giving us. It's asking for the title and the scale. It's asking for the projection symbol of what we have done on the previous session. It's been cut on AA. So there we go with the cutting plane on AA. And now we're going to cut it off in half, and we're going to show what the detail looks like if we cut this in half. All right, so if we go to this view, this is where we're going to end up. You can see it's been cut. There's areas not cut. There's areas not been cut over there. And there's the engine, if you can see that way. The lights are apart from each other. So therefore, this is the principle what I've showed you in the slideshow just now, where something is deeper. So that line will be there. It will be visible in that area. This is the symbol itself. And now, of course, the examiner placed the view in such a way that the option is open to either draw the view on this side and the view on that side. So the examiner is testing you. Do you know that the right view will be placed on the right hand side? And that's what you see why the spacing is not 100% correct of what I've taught you, but this is the examiner's way in finding out, do you have the subject knowledge in this? All right, so this is one question. Another question I can maybe point out to you is this one over here. So the examiner is asking for a sectional front view on the cutting plane AA. But wait, there's another section view. There's a sectional right view on cutting plane BB. All right, so there's two cutting planes over here, and then he's also asking for the top view. So there's three views involved into this question. No hidden detail. Insert the title and scale and draw the correct symbol for projection. All right, so the symbol of projection has also been asked in this regard. All right, so if we go towards this, this is what the examiner is giving. This is some sort of, it looks like a spaceship. If you can see that way, the engine room will be inside here. All the people will be operating in this, and the gunner at the back of the ship will be in that area over there. So yes, there's the cutting plane. It runs all the way up there and it goes all the way up to that point, and there's another cutting plane over here. All right, so it's asking for cutting it on BB over there, but also on AA in that regard. All right, so this is the question part. Now the examiner just gave the learners point BB and the starting point at T. Why? Because he wants to show or emphasize that specific point that you see over there, halfway from the bottom to the top. You have to cut it off, so in other words there. So you have to start with T, which is that position over there. It's also been placed over there. There's also T pointed out to you in that regard. So this is where we go, starting with T, cutting plane BB, and he was nice to the guys and say, all right, listen here, this is already the distance between the front view and the top view, the distance between the front view, and in this case, asking for a right view, section the line on AA for the right view itself. All right, so the answer of this part over here, that's the last thing I want to point out to you. This is the answer. You can see the detail, although there's a hole being cut in. Remember, the hole won't be hidden detail anymore. The hole will be visible now. There was no saw marks inside the hole. There's no saw marks inside this counterbore hole that you see over there. There's an open area, but at the end of it, it's closed there. So therefore, you can't see right through to the other side. It will be like a slanted line that you see in that case over there. And that point, that will determine the cutting points at this point over there. From the bottom on its way to the top, it's been cut at that specific point. So the cutting plane starts at that point, and then from there on it goes further down. Can you see it's a casting? There's no seams, there's no solid lines in between there, and there it's not pasted onto one another. It's one unit melted in. There's your symbol, there's the heading of the drawing. And yeah, ladies and gentlemen, thank you very much for attending. Thank you very much for pitching up for this session. I hope that this will help you to level up for the grade 10 level on castings and castings that's been sectioned, and the different views, the placement of the views, where to place those views, how to cut, how does the body of an object change once it's visible and once it's been cut and taken open. So yeah, hopefully this will help you a lot in interpreting the drawings itself. Remember that the wording of the drawing is front view, left view, and top view, or maybe a section front view, maybe a section right view, whatever the case might be. But the object will change as far as you go. New objects needs to be cut, new objects needs to be drawn in front view, left view, and top views, or right views and bottom views. All right, so this is what I want to say to you. I thank you for listening up to the end, and I really sincerely hope that you will benefit from this session. Thank you very much.